Hey, good morning, everybody. Uh, let's do this, right? It's Tuesday, happy Tuesday, January 12th, cruising through this year, right? This year looks promising. Again, that light at the end of the tunnel seems to be getting brighter and brighter. I'm hoping to see some of you in person this year. Uh, Looking forward to it. All right. You know the drill. Copy this down, go try it, come back for hints if you need them, or come back and check and see how well you did. Okay, we'll see you in a bit. Amazingly fast. Right, that pause button, gotta love it. All right, so diamonds, they're back. They're back. All right, what two numbers have a product of 45 and a sum of 14? Hopefully you figured out that is 9 times 5 and 9 plus 5. Again, what is the property in math that says that 9 times 5 is the same as 5 times 9? Anybody remember that one? It's good to know. It's just a vocabulary word, but it always seems to come up in those state tests. So if you know commutative property says that when you add or multiply two numbers, the order does not matter, right? 9 plus 5 is the same as 5 plus 9. 9 times 5 is the same as 5 times 9. That's not true with subtraction and division, right? Commutative property. Okay. All right, 39 and 16. I know that 3 goes into 39 because 3 plus 9 is 12 and 3 goes into 12. How many times? 13, which fits perfectly because 3 plus 13 is 16. How about 1800s and 9/10? I know 9 times 2 is 18. This is weird, Mr. Dan. Check it out. 6 times 3 is also 18. And when I add those, remember what you're supposed to do when you add decimals is stack them, and the decimals should go one on top of the other and come straight down. So when I add, you see that I get 9/10. When I multiply, your job is to pretend there's no decimal, and you just multiply. 6 times 3 is 18. But in order to pretend this was a 6, I had to move the decimal one spot to the right. In order to pretend this was a 3, I had to move the decimal one spot to the right. That's a total of 2 spots I moved the decimal. So I have to go back 2 spots in my answer. Remember, that's why I move it 2 spots. Don't count the decimals. Okay, a lot of kids count the decimals and they think that's why I moved it back 2 spots because there were 2 decimals. Don't do that. Count how many places you actually had to move it in the problem to pretend it wasn't there. Okay? All right. 1/6 and 5/6. This ends up being 1/2 and 1/3. Remember, multiplying fractions is what? Hopefully you yelled out so loud that someone came in from the other room to find out what you're yelling about. And you said, multiplying fractions is easy, right? It's easy. Why? Because you go straight across the top, 1 times 1, straight across the bottom, 2 times 3, and you're done. Boom, mic drop. Boom, I'm out of here. See you tomorrow. Okay? When you add, though, you have to find a common denominator. 2 and 3 go into 6. 1/2 ends up being 3/6 because I did 2 times 3. I go 1 times 3. 1/3 ends up being 2/6 because 3 times 2, 1 times 2. 3/6 plus 2/6 is 5/6. All right? Challenge, huh? All right. Absolute values. What is the absolute value of -8? How far is -8 from 0? 8 spaces. What's the absolute value of -7? How far is -7 from 0? 7 spaces. But that negative is still out there. So my answer to this whole thing is -7. If it was just the absolute value of -7, the answer would be 7. But that negative does not get erased if it's outside the box. Same thing here. Absolute value of 7 is 7, but that negative is outside the box, so I still need it. What is the absolute value of 8? How far is 8 from 0? A lot of kids want to make this negative. No, it's just 8 spots. All right, 9 minus 2 is 7. The absolute value of 7 is 7. 2 minus 9 is -7. I had $2. I spent 9. I owe somebody $7. Right? And what's the absolute value of -7? It is also 7. That's kind of cool. Right? The absolute value kind of makes, right? If it's absolute value, then for subtraction, it's almost commutative, huh? Right? But don't mess with it. All right. Absolute value of 9 is 9. Negative absolute value of 9 is -9. Absolute value of -2 is 2. How'd you do on those? Okay, now we said multiplying fractions is easy. Adding and subtracting is a little bit tougher, especially when you have different denominators. You got to do a little extra work, right? I usually write these vertically. That's one on top of the other because I know I have to change the denominators, and it gives me space to do it to the right, okay? Now, what number do 3 and 5 go into? Well, 3 times 5 is 15, right? Here I did 5 times 3, so I got a 1 times 3. Remember, you have to multiply the top and the bottom by the same number. Here I did 3 times 5, so I don't put a 5 here. I go 2 times 5. Catch that? Okay, that's a popular mistake, okay? And that's why I always say I did 1 times 3 to get that. I didn't put the 3 there. Okay, 10 fifteenths and 3 fifteenths is, 13 fifteenths. 7 eighths minus 1/4. Now, why am I lucky on this problem? Because 4 fits into 8. So I'm going to change these to 8s, which means I didn't have to do any work on that one. I just rewrote it. Cool, huh? All right, I did 4 times 2. I got to do 1 times 2. 7 eighths minus 2 eighths equals 5 eighths. 1 2/3 plus 3 1/4. What number do 3 and 4 both go into? I don't know if you notice, I just put the whole number over there. That's not changing, right? Just the fraction part. 3 and 4 both go into 12. So I'm changing these to 12ths. Here I did 4 times 3. I did 1 times 3. 3 12ths is the same as 1/4. Here I did 3 times 4. I'm not putting a 4 there. 2 times 4. Okay, so now I have 8 twelfths plus 3 twelfths is 11 twelfths, and 1 and 3 is 4. Okay, now I'm going to rewrite these, stacking them one on top of another. And the next thing I do here is I realize I have fifths. The most popular wrong answer for this problem is 4 and 2/5. They just bring that 2/5 down. Okay, but really what I do to keep me from doing that is I say, how many fifths are up here? Well, there's 0 fifths with the 6, the 7, right? I can't take away 2 from 0, so I got to borrow. Now, don't go put a 1 there, right? Because think about what you're doing. You're borrowing 1 whole because you needed fifths. How many fifths do you get for 1 whole? If you put a 1 there, you're saying that 1 whole equals 10 fifths, and that is not true, right? 1 whole equals how many fifths? Hopefully, you're saying 5 fifths. The same number on the top as on the bottom makes that 1. So now I have my 5 fifths. I can take away 2 fifths and get 3 fifths. And now I have 6 minus 3 is 3. Okay, real quick, let's think about what I did there. I changed 7 to 6 and 5 fifths. Well, 5 fifths is 1 whole, right? So that's why I'm allowed to do that. Does that make sense? Okay, solving algebraic equations. Remember our steps here, right? What is my goal first? That's the question you ask yourself first. What's your goal? And your goal is to put the letter, you want to solve for that letter, find out what that letter equals, right? So if you put A equals something, the A is all alone on one side of the equal sign, right? And we say it is isolated. When you put someone or something all alone, you isolate it. Okay? So I want to isolate the variable. Remember what that is. Isolate the variable is to put, when you isolate the variable, you have an answer, right? You have it A equals something, right? So that's the first thing. And remember what isolate means. I-S-L-A. You speak Spanish now because you know that isla means island. Okay, so we're going to put that variable on an island all by itself. Okay, so I know I want to get the A all by itself. Who does the A have to kick off the island so he can be all alone? Well, hopefully you said not just 4.2, but what? What else is there? Minus 4.2, right? So the first step is isolate the variable. And then you're saying, okay, how do I do that? I got to get rid of something. What am I getting rid of? And how do I get rid of a minus 4.2? Well, you do what's called the inverse operation, right? inverse operation, and I think I put one too many p's in there. Too much pee in the pool. All right, inverse operation is the opposite. And now I'm not sure if there's one or two p's there. You ever do that? You see something wrong and you're not sure what's right now? Okay, inverse operation or the opposite. What is the opposite of minus 4 2/10? By the way, don't tell Miss Mulligan I don't know how to spell, okay? All right, what is the opposite of minus and 4 2/10? Hopefully you're saying plus 4 2/10. And hopefully now you're saying, wait, something's weird here. Mr. Daniel always said that that equal sign is like a perfect balance, right? Everything on this side is balanced with something on that side. If I add 4.2 to this side, won't I be out of balance? Won't I sort of sink to this side and be leaning that way now? Yeah. How do I keep from doing that? And this is where the bracelet comes in. DTS, TTT, OS, do the same thing to the other side. You can do anything to one side, as long as you do the same exact thing to the other side. So if I added 4.2 to this side of my equation, I have to add 4.2 to this side so it stays in balance, so it stays equal. Okay, so why did I do that? Because these opposites cancel each other out. They go away. I have a minus 4.2 and a plus 4.2. Put them together, poof, they're gone. Right? Which is what I wanted. I wanted the A all by itself. Now, what's on this side? I have 17 8/10 plus 4 2/10. Okay? So let's go see what that is. Write it. Remember when you, whoops, 17 8, 4 2. You have to stack those decimals when you add decimals. 8 plus 2 is 10. Carry the 1. 8 and 4 is 2. Carry the 1. 22.0 or is 22, right? Now, I have the solution or the answer. They call it a solution too. How do I check it to make sure, right? This is a test. I want to make sure I got it right. If A actually equals 22, I should be able to substitute 22 in wherever I find an A and rewrite my problem. 22 minus 4.2 should equal 17.8. Is that true? Well, let's check it. 22, I'm going to go and put that decimal back and write 22.0. That way I'm lining things up. And then I got to go borrow, right? So I'm crossing that out. I have 10 minus 2 is 8. Remember, the decimal came straight down, and 21 minus 4 is 17. Boom, we did it. It works. All right, let's try this next one. Again, we start from the beginning. What is my goal? My goal is to isolate the variable. Okay, now what does that backslash means? That means divide. So I'm going to rewrite this, and I'm kind of combining two steps here and giving myself space to do the opposite, right? How do I get rid of a divided by 2.3? Well, I do the inverse operation or opposite. And what is the opposite of divide? Multiply. So if I multiply this side by 2.3, how do I get rid of that? But something's weird. I just multiplied my perfectly balanced equation on one side, and now it's leaning. How do I bring it back in balance? Hopefully you guys are pointing at that, right? Do the same thing to the other side. 2.3, right? Okay, and remember, these opposites cancel each other out. So you end up with x on this side and 6.8 times 2.3 on this side. Pretend like there's no decimal there. 23 times 68. 8 times 3 is 24. 3 times 6 is 18 plus 2 is 20. Put a placeholder because this is really 20, not 2. 2 times 8 is 16. Carry the 1. And 2 times 6 is 12 plus 1. Now I add, and I get 1,564. But I know that I had to move the decimal over once there and once there to pretend they weren't there. So I had to go back 2 spots of my answer. My answer should be 15.64. Okay? Now, the tough thing here is when I go to substitute to check, we have to do something we haven't done before. 15.64 divided by 2.3. 15.64 divided by 2.3. Now, I wrote it like that first because we have learned how to divide with a decimal inside the box. We just bring it up. We haven't learned how to do it with outside the box. Okay? And I want to show you something. If I write my division problem like this, I can multiply this by 10 over 10, which is 1. And then if I do that, each of these decimals go over one spot. So 15.64 divided by 2.3 is the same as 156.4 divided by 23. Okay? And there is another way I teach this that you will learn later. Okay? But if you have to and you haven't learned how to do something, you just go get a calculator out and divide to double check, right? Okay, and then you ask your teacher, hey, how do you do this? Right? Now I only have a decimal inside the box, I go up, right? Now 20 goes into 147 times, but that 7 times 3 is 21, so that's going to be too big. So I'm saying 6 times here. 18, carry the 1, and 12, 13. Now I got to subtract 18, 4. How many times is that going to go? I think this is a nice even 8, right? 8 times 3 is 24. Carry the 2. 8 times 2 is 16. The plus that 2. Perfect fit. 6.8, which is, well, we got it. Okay. All right. Sorry for slipping that in there, that dividing with a decimal outside the box, but hopefully everything else was nice and clear and easy. All right. Have a great Tuesday, everybody.